Hey ladies, in this video we're going to go through 7C, which is sketching parabolas using factorisation. Now if you think back to chapter 5, you know how to factorise quadratics. So try to kind of reflect on what we did in chapter 5 and try to remember back how to factorise because, we've looked at how to sketch them other ways, but that you can factorise a quadratic and sketch them that way. The purpose of factorising or using factorisation is to basically get your x-intercepts, because when we let our equation equal 0, we're effectively letting y equal 0, which is finding the x-intercept. So I just thought I'd quickly show you here, which is in your textbook. So we find the x-intercepts, and when we have found the x-intercepts, we can find the turning point, and the y-intercept is basically when x equals 0. So you can find that easily as well. So we're going to focus on factorising for this one. So factorising first to find the x-intercepts, and then using those x-intercepts to find the turning point, and then letting x equal 0 to find the y-intercept. Do remember, though, that not every parabola has an x-intercept or x-intercepts. So your parabola can move above or below your x-axis, or the turning point can go above or below the x-axis. If it was an upside-down parabola, they wouldn't have x-intercepts, or your parabola could sit on the x-axis, so it only have one intercept. Let's just scroll through. I think I might have to pause in a sec because people are moving around and might get a bit too noisy. I'm not going to go through all these examples. Okay, I'm going to go straight to question 4. I've got it on a Word document anyway, but I'm just going to quickly talk you through maybe the first 3 questions. Remember, there's examples associated with them, and there's videos on your online textbook if you want someone to talk you through the examples as well. So for question 1, when you're factorising, we've got y equals x squared minus 8x. Take out x as a common factor and then factorise. You can also think about what your quadratic might look like based on, your constant will always be your y-intercept. So for this one here, it hasn't written a constant, so it's plus 0, so your y-intercept is 0. For B, your constant is 3, so your y-intercept is 3. So you can kind of get an idea of what your quadratic is going to look like. But if we were to factorise this first one, x would be taken out as a common factor. For B, you would think of 2 numbers when multiplied give you 3, and when added give you -4. So those numbers would be -3 and -1. So as I've spoken about them, hopefully you're thinking, oh yeah, that's right, I remember how to do that. Okay, we're going to start with question 4 and then do some more down here. So I've just got them on a Word document. I'm going to get them open so I can write and get my little tablet next to me. Okay, so I've chosen to start at question 4 just because, they're a little bit harder than the ones before. I'm not going to do every single question because you know how to factorise. It's now just using this information to sketch your quadratic. So you need to be able to do this by hand, but obviously you've done a lot of work on your CADS calculator already, so hopefully you know how to sketch these on your CADS. Okay, let's do the first one. So we've got y equals x squared minus 9x plus 20. So we need to find 2 numbers when multiplied give us 20, and when add give us -9. So I always, when I do factorising, I set up my brackets, okay, use my variables. So in this one it's x and y, which is nice. And then I've got my spaces already for my 2 numbers to go in. Now, because this is a positive and this is a negative, it means both your numbers are going to be negative. Okay, so when you multiply 2 negatives, you get a positive, but this negative here means that they both have to be negative. Okay, so it's going to be -5 and -4. Now, we've factorised it now. So what we have to find is the x-intercepts, and we let y equal 0. So we did this in chapter 5. Remember, we did the null factor law. So x minus 5, x minus 4 equals 0. So the null factor law just means x minus 5 is equal to 0 or x minus 4 is equal to 0. And then we just separate. Well, not separate. We just solve. So we've got x equals 5 and x equals 4. So they're our two x-intercepts. When I sketch them, so let's just get our axes up. Now, when you're drawing your axes, don't go and do a scale, okay? When you're sketching, we're not in art class, so we just need to have an idea of what it looks like. This is probably definitely not to scale, but that's 4 and that's 5. Now, because parabolas are symmetrical, your turning point is going to be halfway between these two. So I can see quite easily that halfway between 4 and 5 is going to be 4.5. But if you're unsure, you can just add your two x-intercepts together. So 5 plus 4 and divide it by 2. So 9 divided by 2 gives you 4.5. Okay, so sometimes it's easier to see what they are, and sometimes it's not. Okay, so your x-coordinate of your turning point is 4.5, but we need to find the y-coordinate. So we're just going to substitute in 4.5 into this, plus 20. Okay, and then we need to solve. Now, obviously, you couldn't do this, or you could do it by hand, but it would probably take you a long time. So you can do it on your calculator, and I'm just going to get my calculator and do it now. Actually, guys, while I was doing this on the calculator, I did think you can actually do this by hand. The easiest way would be to convert that 4.5 into a fraction. Excuse me. Now, I don't know whether I'm going to be complicating things by doing it this way. So let's just see. So 9 squared is 81, and 2 squared is 4. 9 times 9 is 81 over 2 plus 20. So because we've got two fractions here, let's have them at the same denominator. So that's going to be 162 over 4, sorry. So what do we got? 81 over 4 minus 162 over 4. So we're left with 81 over 4 plus 20. And then we can put it back as a decimal. So 81 divided by 4, 80 divided by 4 is 20, and then we've got 1/4 remaining. And that should be a negative, shouldn't it? Oopsies. Plus 20. So you're left with negative, it's a negative 0.25. So your turning point, your x-coordinate, what was it? Oh gosh, I can't even remember. 4.5. Negative 0.25. Now, girls, I encourage you actually to try to do it by hand using fractions. I find fractions easier to square and multiply than decimals, but if you can, you're okay with decimals, then go ahead. But if you're not, maybe just use your calculator, or use a combination of both. So go as far ahead as you can without a calculator, and then use your calculator to support you. Okay, so going back to our graph, we're here. Again, probably not to scale. So we've got negative 0.25. And we've got to put in our y-intercept. Oh, this is terribly not to scale. So not the best example of how to draw a quadratic, but we've got the important features there. Okay, so there it is. And we've sketched it. So starting with finding your x-intercepts, finding the x-coordinate of the turning point, using that to find the y-coordinate. So remember that was 4.5, negative 0.25. And then your y-intercept, you let x equal 0 or it's just your constant. All right, let's do another one from question 4. Okay, let's do a harder one. I might do I haven't even decided whether that's hard. I just looked down. So y equals x squared minus 5x minus 14. Okay, so two numbers when multiplied give you negative 14 and when add give you negative 5. So as we did before, just set up your brackets. Got x's. I think doing stuff like that, it gives you a little bit of confidence. Yeah, I know what I'm doing. Before you get to the hard parts. Because this is a negative, that means one of your numbers is going to be negative, one's going to be positive. And so two numbers, it's not hard to find the factor pairs of 14. So it's going to be 2 and 7, but which one's negative and which one's positive? So if we had negative 7 plus 2, we're going to have 5. So we're going to deal with x plus 2 times x minus 7. Now to find your x-intercepts, we let y equal 0. So we're going to have x plus 2, x minus 7 equals 0. So hopefully by this stage you can just say, all right, x equals 2 and x equals negative 2 and x equals 7. So they're our two x-intercepts. So I'm going to change the colour of my pen. Okay, and so we've got negative 2 here and 7 somewhere along here. Okay, so there are our x-intercepts. Your y-intercept we can put on as well, so I might just make that axis a bit longer. My stomach is rumbling. Okay, well that you really need to know that, did you? Okay, so it's negative 14. Okay, so I know it's got to go down there, and your x-intercept is halfway between negative 2 and 7, so I know it's going to be roughly around here, because when you kind of picture the parabola, it's going to go down and then back up again. Now, to find the halfway point between negative 2 and 7, you can just add them together and divide by 2. So negative 2 plus 7 is 5. So you're going to have 2.5. So we're going to be roughly, yeah. And then to find the y-coordinate, remember we substitute that into our equation. So we've got y equals 2.5 squared. So I'm doing I, that's where I'm getting my values from, minus 5 times 2.5 minus 14. Now, again, like before, you can do this by hand. So we can write that as a fraction. Probably should have left it as a fraction from the beginning, huh? Minus 14, and that's squared. Getting a bit sloppy with my handwriting, sorry. 25 on 4, minus 25 on 2, minus 14. Okay, have the same denominator. So I'm going to have minus 25 on 4, minus 14. Now put this as a mixed number. So 4 goes into 25 6 times. So it's going to be negative 6. And we have one remainder. So negative 6 1/4 or 0.25 minus 14. So our y-coordinate is going to be negative 20.25. So going back up to our axes, remember I said it was going to be down here somewhere, so that's good. You know, it's always good to think about what your answer, oops, that should be a bit over a bit more. Think about what your answer should be. Oh, this is going to be terrible. Sorry. Oh my gosh. think that's probably the worst parabola I've ever drawn. Okay, so that turning point is 2.5. And what was it? Negative 20.25. All right, so question 4 a little bit harder because we're dealing with fractions. I don't think we'd probably have to deal with fractions earlier on. All right, I'm going to skip now to question 5. Oh no, have we drawn everything? Yeah, we sketched it, didn't we? Good, good, good. Okay, I might just have a drink. I'm sitting right next to the heater in room 6 and it gets a bit hot. All right, so question 5. Sketch graphs of the following perfect pairs. So this just means perfect pair. Oh, I didn't do it in pink, sorry. All right, so perfect pair just means it's going to be x plus 2 squared. So two numbers when multiplied give you 4 and when add give you 4x. So that's going to be x plus 2, x plus 2. And because we're multiplying the same thing, we can just write it like this. So that means you only have one x-intercept. So we've got x plus 2 equals 0. So that x-intercept is at negative 2. So when we're sketching out, oh gosh, what did I just do? Sorry. Oh, where did I go? There we go. When we're sketching our parabola, and hopefully your parabolas are looking a lot nicer than mine, negative 2. Okay, so we've only got one x-intercept. Our y-intercept, remember, is our constant, so that's going to be 4. And remember, your quadratics are symmetrical. So if we've gone across to here and then up 4, oh, sorry, it's not very neat. Then we do the same on this side, across 2, so then would be now negative 4. And then up 4. So our other point is going to be here. So if you ever, if you ever need to draw a quadratic, you kind of need at least 3 points. And because parabolas are symmetrical, you can just do it that way. Okay, so, oh, that was supposed to go through 4. And that goes through negative 4, 4. Okay, so there's your quadratic. Let's do another one, just because I feel like that might have not been the best example. Okay, let's do D. X squared plus 20x plus 100. You know, I've brought a salad for lunch today because it's 12:30 before our maths class, and I didn't bring a fork. And I was driving to work this morning thinking, how am I going to eat my lunch? So I'm hoping I can find a fork. It's a bit hard to eat a salad with your hands. Okay, so it's a perfect square, so it's 10. Okay, so 10 times 10 gives you 100. 10 plus 10 gives you 20. So when we're finding out x-intercept, we'll let y equal 0, so x equals negative 10. So it's a parabola at x equals negative 10. So just put that here. Your y-intercept is at 100. And remember, it's symmetrical, so we can just go over another 10. So negative 20, and our other point is up here. So going up and up there. So we've got this point here is negative 20, 100. Okay, because when you're sketching, you can clearly see x-intercepts and y-intercepts, and your turning point is the same here as your x-intercept. So you can't really say, well, I've got 3 points. I've got my x-intercept and the turning point because they're the same thing. So you need to have another point. Okay, let's move on now to question 6. I'm going to remember to change the colour of my pen. 6A. So now we've got difference of perfect squares. Now, I like ones like this because I can picture what they're going to look like. So we've kind of covered this already. So if you look at this, I'm hoping you see that as a parabola, a positive parabola that's just been moved down 9. but let's use factorising. So because this is the difference of perfect squares, remember we identify A and B. So in this case, A is x, or the square root of x squared, and B is the square root of 9, which is 3. And then we've got A plus B, A minus B. So when we factorise this, we're going to have x plus 3, x minus 3. So your two x-intercepts are going to be x equals -3 and x equals 3. Your y-intercept, remember, is your constant here at 9. Now, I know what my turning point is because I know this graph has gone down 9, but you can do it the same way as we did before. So halfway between -3 and 3 is 0, so turning point. That's it. Dot, by the way. Halfway is 0 between those two. And when we put 0 in here, we get -9. Okay, so when you think about this parabola, it was your standard parabola shifted down 9. So -9. So your turning point is still on that axis. So it's 0, -9. And I've pretty much just sketched it for you, but it was a terrible sketch. So let's do a bit nicer one. Not that my other sketches have been terribly, great, but sometimes I'm filming and then I'm like, am I actually recording? I am recording, so it's good. Okay, and there's, it's -9. And then we just draw the best parabola that we can. It's a lot easier to do it on a piece of paper than on the computer screen. Okay, let's have a look at question 7. Question 7, and I'm just keeping note of the time. They're very similar as what we've done before, but take out a common factor first. So you can see A and B have already taken out a common factor. That 2 in the first case and this 3 doesn't make any difference to your x-intercepts or your y-intercepts. It basically makes your graph either narrower or wider. Okay, so A and B I'm going to skip and let's do C. So I'll show you, do 1 because in case you don't understand what I mean by taking out a common factor. So we look at the coefficients, so 3, 18, and then the constant 24. So 3 is a common factor, so we take out 3 as a common factor and we're left with x squared plus 6x plus 8. And that 3 is kind of redundant when we're trying to sketch it, but let's do it anyway. Okay, so let's factorize this in brackets. So let's set it up, x and x. So two numbers when multiply give us 8 and when add give us 6. So that's 4 and 2. Now to find your x-intercepts, we let y equal 0. Now I know the question is asking for the turning point, but because the question's focusing on factorizing, we'll do it this way. If you wanted to turn it into turning point form some way down the track, you can do that as well. Okay, so let's let y equal 0. I always write 0 on the right-hand side, so if you're wondering why I do that, equals 0, it's just because usually you say it that way. Then we can divide both sides by 3, so when we do that, that disappears. So we're just left with x plus 4 equals 0 or x plus 2 equals 0. So x equals -4 and x equals -2. So we have to do the turning point. So remember your turning point is halfway between these two. So we can add them together, or you know that it's going to be -3, but anyway, let's just add them together anyway. So it's -6 on 2, which gives you -3. So the x coordinate of that is -3. And then to get the y coordinate, we just substitute that in. Okay, so we've got y equals 3 times -3 squared. Now we don't need to, I'm just thinking, probably should have done this beforehand, whether we need that 3 there. That's 24, I think we do. 18 times -3. Good. Just making sure I've written it down correctly. Okay, so -3 squared. Now, if you're squaring a negative number, remember it becomes a positive. So -3 squared is 9. So 3 times 9 is 27. 18 times -3. So 3 times 10 is 30. 3 times 8 is 24. So that's going to be 54 or -54 plus 24. Okay, so 27, so that's -27 plus 24 is -3. So your turning point, oh, written it up here, is at -3, 3. Yeah, sorry, -3, -3. I was just checking the answer on the calculator. I wrote -3 here, but I didn't write -3 up here. Okay, so your turning point is at -3, -3. All right, now question 8. Okay, so with this time we've got the graphs. Now notice how it's told us that the form of the equation is y equals x plus a, x plus b. So a and b, we look at our x-intercepts, okay? But we don't have to worry about a factor here in front of everything. So we're just assuming that's a factor of 1, which kind of makes it easier to do the turning point. Okay, so let's have a look at question 8a to begin with. So our x-intercepts are at x equals 1 and x equals 3. So when we are doing the equation of this, we're going to have it at x minus 1, x minus 3. Okay, because remember when we solve this, we get x equals 1. So your sign isn't x plus 1, it's x minus 1. Okay, so we're kind of doing the reverse now. So before we factorized and graphed, this time we're using the graph to get our factors. So x minus 1, x minus 3. Now, we've got to find the turning point. So the turning point is halfway between 1 and 3, which we can easily do. So the turning point, if not, just add them together. So 1 plus 3 is 4 divided by 2 gives you 2. Or you can see it's quite easily, it's going to be 2. Now to get your y coordinate, we just substitute 2 into our equation. So we're going to have 2 minus 1, 2 minus 3. So 2 minus 1 is 1, 2 minus 3 is -1. So your y coordinate is -1. And you can have a look at the graph and you can see that it is below. Okay, so if you got +1, you might think, oh, I've made a mistake somewhere. All right, so that's question 8. Hopefully, girls, you got enough theory now to do the rest of 7C. Good luck, a long video, but it's a good thing I'm very entertaining. Bye.